Hello everyone, today we're going to talk about dilations. What I want you to do today is to please make sure you guys make the lines for corner notes. Title this as dilations. I know that yesterday I gave you guys these two papers for you to cut and glue on your ISN. We also highlighted some of them, but we're going to come back to this after I talk to you a little bit more about dilations. So while you guys are watching this video, I want you to please pause it and copy the notes that I will be collecting and giving you a grade based on your notes. So go ahead and let's go ahead and take a look at the notes. Okay, the first part, I'm going to talk about dilations. So make sure we have the title. Dilations is a transformation that changes the size of a figure, creating two similar figures after applying a scale factor. Remember the scale factor? Many of the textbooks label it with the letter K. The scale factor again, scale factor is labeled with the letter K. The formula to find scale factor is given by the ratio of corresponding sides when the new corresponds to the old. Remember that when you look at the figures or exercises, there are many ways to also name the new figure. We also call it the image, and the old is the pre-image. You can also think of the old as the original, and the image or the new is the result of applying the scale factor. Keep in mind that it is a factor, so you guys are going to multiply the scale factor to find the new measurements. Let me move this up a little, and we're going to talk a little bit more about scale factor. Whenever your scale factor is greater than 1, it is going to create an enlargement. That means I'm going to multiply times a number that is greater than 1. Because the number is greater than 1, when you multiply times a number more than 1, you get something bigger. And if the scale factor is less than 1, it's going to make a reduction. Remember that K is a rational number. That means it could be a fraction, a decimal, or a percent. It's also a positive number, which means that I cannot have a negative measurement. So my scale factor will always be greater than 0, but if it's less than 1, it's going to be a reduction. The algebraic representation is the next thing that I'm going to talk to you about. The algebraic representation for dilations, it's a rule. It's a rule that produces my transformation. Since K is the number for which you multiply to create the image, the rule is given by x is x comma y becomes K times x. Because remember, I'm going to multiply times K. K times x, comma, K times 1. So that means that if my input point has the coordinates 2, 4, and I use the formula 3x, 3y, that will produce the point 3 times whatever the x is. In this case, my x is equal to 2. So that's going to be 3 times 2, 3 times 4, because the y is equal to 4 right here. Let me see if I have another highlighter. That's going to be my y. So I'm going to multiply times the y value, which produces the point 3 times 2, which is 6, 3 times 4, 12. Notice that my scale factor is K. This is my scale factor right here, scale factor right there, which is this, and that should have been a 3 right there, I'm sorry. 3. Okay, now you guys can pause this at any time and rewind it to make sure those copies are ready. But I'm gonna continue on the next page since this is ready. So on my next page, I'm gonna talk about an example of dilating a shape on the coordinate plane. My instructions are asking me to write the algebraic representation based on these two figures. Let me show you how to do this. Normally, if I'm given two shapes, like maybe a little triangle, which is 3 by 9, and I use a scale factor of 2. I'm going to multiply times 2 to change the sides. So I multiply 2 times 3 and 2 times 9 to get the new measurements. Notice it is more than 1, so this is going to make the shape bigger. So this side is going to be 2 times 3, which is 6, and this one's going to be 2 times 9, which is 18. I know you guys don't have this paper. You don't have to put this on the notes. This is just for you to follow my example. But I want you to see what happens. I'm using the scale factor to make it bigger. Now let's say I have the shapes, but nobody gave me the scale factor. I will be able to find the scale factor by using my formula new over old. I'm going to label this as A. This will be my A prime. We take any measurement from the shape that is the new one. Remember, this little prime identifies the new shape. So that means that one of the sides, 6, corresponds to 3. And 6 divided by 3 is equal to 2 because the scale factor was 2 and it got twice as big. I'm going to use the same concept. But now I'm looking at shapes on the coordinate plane. So let's take a look at this one. Forget about this. Now, for me to come up with the rule, I know the rule is going to start with x comma y. And it follows by k times x, comma, k times y. So what I need is the k. If I know that k is 2, then I can just put a 2 right there and I'm done. But I don't know how much it is. I'm gonna find it though. K is the ratio of new over old. So let's look at these two shapes. Which one is the new shape? Okay, we can clearly see that this one will be the new one because it has those little primes on each of the letters. So if this is the new one, I can pick any of the sides. So I'm going to take this side, for example, and count. 1, 2, 3. So how much is the new? 3. And 3 corresponds to this one right here. How big is this one? 1. So 3 corresponds to 1. 3 divided by 1 equals 3. My scale factor is 3. So then to come up with the formula, pretty simple. X comma y becomes 3 times x, comma, 3 times y. So this will be the answer to my question. Do we understand? Now, this is a very simple example. Sometimes we may have shapes in which we will not be able to count. I want you to go back to the example that I gave you. You guys can flip the pages over and look at this particular example. And I want you to see what happens. When you look at this one, sorry, this takes a little while, you guys know. Okay? When you look at this, which one is the new one? The small or the big? I know what you guys are thinking. You recognize the prime notation right there, and that is the big picture. So when finding the scale factor, which is k, I'm looking for the ratio of new over old. But I'm going to try to see if I can count. Can I kind of count how long this is? Or maybe this side? Or maybe that side? I hope you say the answer is no, because the line, it's at an angle. It's not perfectly going through the intersection of the points, like from here to here I could count, but this one isn't going that way, so I can't count. I'm gonna be using a different process. So in a case like this, if you guys are not able to count, you have to look at each of these coordinates, any of them. So I'm gonna look at Q first. Now look at this and show me what are the coordinates of Q. Q has an X and it also has a Y. So let's take a look at Q, and we see that the X is 2 and the Y is 8. So Q is 2, 8. Now I'm going to look at Q prime also, and let's see what I get. Okay, Q prime. I'm looking at this one right here, and I can see that it goes through the middle and that. Notice that this particular example is going by 2, and this is right in the middle, so between 2 and 4 is 3. So 3 corresponds to 12. So the coordinates for Q are 3, 12. Then you use the same formula. Pick a number from the new. Who is the new one? Q or Q prime? Quickly, Q prime is the new one. So pick any of these two. So to find K, I'm using new over old, right? The new is 3. And the old, 3 corresponds to 2. This is my scale factor. 3 divided by 2, which is 1.5. What if I pick the Y's instead? If I pick Y, then how much is the new? 12. So then K is going to be new over old again. And in this case, I'm using the 12. And the 12 corresponds to 8. Simplify this fraction. Half of 12 is 6. Half of that is 4. Half of that is 3. Half of that is 2. Get the same thing again. So you get the same answer, whether you use X or you use the Y's. And it comes up to the same answer when you use S and S prime and R prime. You should be getting exactly the same answer, 3 over 2. So we found that K is equal to 1.5, right? So then, if K is equal to 1.5, the rule is simple. X comma Y, my algebraic representation, X comma Y, it always starts with the X and the Y with the arrow. And we know that we multiply times 1.5. So this is 1.5X, 1.5Y. Notice that this must be the same number. We are not changing the scale factor. I'm not going to multiply one side times one number and then the other side times another. Make sure those two are equal. Okay? I'm going to give you a couple of exercises to practice the following information. So let me just do one more example for you guys on the ISN. So let's put this away. And, I'm sorry, my Elmo always gives me trouble. I'm going to give you the exercises. I need you to please work them out, and please ask me any questions that you may have. Thank you.